So this first part should be pretty easy. Kind of review. What I put on here was when we're solving this, we need to first simplify, and that includes any distributing. So that would include to distribute and also combine like terms. So we're looking at, looks like 6x minus 6 minus 4x minus 24 equals 4x plus 8. Now we're combining like terms. 6 and 4 make 2x minus 30 equals 4x plus 8. 2, let's get the variable on one side. 1 on one side. So I could subtract the 4x or subtract the 2x. Since I want to keep things positive, I'm going to go ahead and subtract the 2x and get that negative 30 is equal to 2x plus 8. And now we can solve using inverse operations. So we do PEMDAS backwards, start by subtracting, so that 2x is equal to negative 38. If I divide, oops, that was not helpful. There we go. If I divide by the 2, divide by the 2, x is equal to negative 19. This next one's a little different because we've got decimals, right? Well, we have a couple options. I can either distribute and leave the decimals. We do have technology that can handle that pretty well. Excuse me. So I can leave the decimals, combine like terms. Inverse operations. What is this? 0.7. And then I would divide. Like I said, I have technology to do 0.7 divided by 0.14. 0.7 divided by 0.14. It goes in 5 times. So we would just put. Now, there are times where we're not going to really want those decimals, so the other option is to take the entire equation and multiply each term times 100. That would turn that 0.08 into an 8, that 0.06 into a 6, not an equal sign there, sorry, and the 1.24 into 124. So basically that 100 would multiply across each term. Okay, we have 3 groups, so it'd multiply with the decimal on each, and then I could solve it. 8x plus 6x plus 54 equals 124. 14x plus 54 equals 124. Inverse operations, 4x equals 70. Divide, and x equals 5. So pick your poison. You can clear the decimals, you can keep the decimals. Either way, the answer should not be different. Now this one, I definitely recommend getting rid of the fractions. Okay, I've done it when I was learning this as a student. I was pretty good at fractions, so I would just leave the fractions. I don't recommend that. I would say that both 10 and 15 go into 30. Now remember, I'm not wanting to make them both a 30. I can. But what's easier is just to multiply each term times 30. We're going to bust some fractions. So 10 goes into 30 3 times. Distribute that. 3x plus 18. 15 goes into 30 2 times. Distribute that. And nothing to clear out there, so just leaves us with 30. So in one step, you can clear out those fractions just by multiplying by the LCD. Then we combine like terms. 5x plus 10 equals 30. subtracting 5x equals 20, dividing x equals 4. Very similar to the one we saw before. Simplify first, distribute. Combining like terms, 3, 4x, about 8x. 2 minus 2 is 0, so that would 0 out. And that leaves us with 8x equals 8x plus 3. That was all step 1, simplify. Step 2, we're going to try to get the variable on one side by subtracting. The scariest thing I've seen people do is say 8x minus 8x and they put x. That's utter nonsense. 8 minus 8 is not 1. It is 0. It goes away. And I get 0 equals 3. We've seen this before. If 0 equals 3, these equations will never be equal. That makes it no solution, or what the book calls a contradiction. Let's do it again with fractions. 6, 3, and 2. I'm thinking of an LCD of 6. This term gets a 6. That 7 also gets a 6. This term gets a 6. That 2 gets a 6. The x over 2 gets a 6. Everything gets a 6, right? It distributes across all the addition and subtraction. So this becomes 2x plus, how about 42, equals 5x minus 12. 2 goes into 6, 3, so minus 3x plus 54. So we have 2x plus 42 is equal to, combining like terms, 2x plus 42. Some of you know at this point that this is a infinite solutions or a identity. Identity is where both sides look the same. But that was all step 1. If you did want to try step 2 and get the variable on one side, all the x's would disappear, leaving me with 42 equals 42. What does that mean? Basically, the x's are irrelevant. This will have many or infinite solutions because it is an identity. Similar, distribute. Negative 8x plus 24. Negative 2x plus 24. Now that's step 1, that's simplifying. Step 2, we want to get that variable on one side. This time, I'm going to add the 8x to keep stuff positive. 24 is equal to 8x plus 24. That was step 2. Step 3, we're going to solve using inverse operations. Now this is a great example because what I will see a lot of people do is get 8x equals 0 and say no solution. That is actually wrong. We still have an x to solve for. To undo the multiplying, we would divide, and 0 divided by 8, x equals 0. That is a solution. Okay? So you can actually get a solution of 0. Don't just make it disappear. Talking about inequalities. I don't know, this one's kind of weird. Let's go ahead and combine the like terms. 6 is less than or equal to 5x. Dividing by the 5. 6/5, or if you prefer 1.2, less than or equal to x. Okay? A lot of people, I can graph from this. I know that this says x is greater. If this bothers you, then learn to rewrite this with the x first. And just keep the inequality open towards the x. So how do I graph this? Not like that. Just need to see more of the screen. Sorry. See if I can get there. Okay. There we go. So we do 0, 1, 2. Somewhere between 1 and 2 would be 1.2. It would be a closed dot or a bracket, shaded greater to the right. Better make sure I did the full instructions because I don't think I did. We got the solution set algebraically. We got the graph form. Do not forget the interval. on the test, if I ask for this, there should be 3 answers. Algebra, graph, and interval, starting at 6/5 as our minimum, and positive infinity as our maximum, with a parenthesis. Okay, so there should be 1, 2, 3 answers on these. Don't throw away some easy points on the test. We're going to take this like we did before, distribute. So for minus 6x minus 18, negative 2 minus 3x minus 18 plus 3x, I'm liking that. On this side, let's see, negative 6x comes down, 4 minus 18 is negative 14. I like that the x's are opposite, so those would make a 0. And I'm left with negative 20 there. So now we're just ready for inverse operations. Adding the 14, negative 6x less than or equal to negative 6. Do not add to undo multiplication. Make sure you divide both sides by the negative 6 to get that x is greater than or equal to 1. That's a big deal. A lot of people will forget to flip there. Please don't forget to flip there. How do I graph it? Pretty easily. We go to 1. Greater is to the right of that. Greater than or equal to means we will use a bracket. 3 answers. Here's our first. Here's our second. What's the third? Oops, too far. Would be the interval, right? And the interval is going to be a minimum of 1 with a bracket going on forever. So there should be 3 answers. The algebraic, the graph, and the interval. How do I deal with this? I would multiply by the reciprocal in this one because I want the x to get by itself. I've found more students lately are more successful by going, let's clear the fraction. That means we're going to multiply everything by 7 and get that negative 4x is greater than 70 and 42 should be about negative 112. To undo multiplying by a negative 4, we would divide by a negative 4 and get that x is, since we divided by a negative, less than, I believe it's 28. Now obviously I'm not going to put 28 little notches, so I'm going to stick a 0. Somewhere to the left we would have 28, or I'm sorry, somewhere to the right. You could go by 4s, 4, 8, 12, 16, 20, 24, 28. I can do that if you'd like. And less than means we're going to be shading to the left of that. Not equal to, so we will use a parenthesis there. And our interval, our minimum this time is negative infinity, and our maximum is 28, and this time both are parentheses. Very similar. I'm solving for the one in the middle. Okay, so whatever I do to the middle to solve it, I do to all 3 sides. So I have negative 4 less than or equal to 4/3 x less than or equal to 4. I would multiply both sides by 3/4. If you want to do that, you can. I found more people are successful by just multiplying by the 3 first, giving us negative 12 less than or equal to 3's cancel, 4x less than or equal to 12. That was kind of cool, not helpful though. Divide everything by the 4, negative 3 less than or equal to x less than or equal to positive 3. So here's 0, negative 1, negative 2, negative 3, positive 1, positive 2, positive 3. X compared to the negative 3 is greater, so I'm shading to the right of that. X compared to the 3 is less than, so I'm shading to the left of that. What do I keep in this situation since it is an and? Anytime I have this combined, it's going to be an and. So I only keep the overlap in the middle, both with a bracket, okay? I will have some people shade past it, As long as you make sure that this is shaded the darker so we know that that's the overlap, really we should only be keeping the stuff in the middle. Just differences. Don't forget our interval. Our minimum this time is -3. Our maximum is +3. I had some other people writing this as -3 infinity and -infinity to 3. I would also accept that, because the and basically says here to the right, here to the left, and only keep the overlap. Choices. Let's get some easy ones out of the way. A, you need to know that this means or. Or means we keep everything. We add them together. So we're basically going to keep everything from A. Oh, geez, I'm not reading right. So hopefully you were screaming at your screen that this is an and, okay, which means we are only keeping the overlap. What is in both A and B? I see a 1 in common. Don't have a 2. They do both have a 5, so we'll keep that in common. And I believe that's it. That would be and, the overlap. Or is where we keep everything. That's the union right there. What would we keep? Well, we keep the 1. Don't write it twice. We only have a 1 that just happens to be in both categories. We would keep the 2. We would keep the 5. We would keep the 7. We would keep the 9. We would keep the 12. So basically, we still keep the 1 and the 5 from the overlap, but or means we include everything else. Solving this, k greater than or equal to 2, and k is less than 9. This is an algebraic answer. The graph, 2 greater than equal to, this was supposed to be less than 9, I don't know what I had there, k is less than 9, weird. So we will stop somewhere over here at 9. Less than would be to the left, and means we only keep the overlap between those two. So between -2 and 9. What's our interval? A minimum of 2, a max of 9. Or some people will write to infinity and -infinity to 9. And I would accept either of those. How does or translate with inequality? Well, let's start with solving it. The minute we divide by a negative, you have to catch that the inequality will flip. Or for x is less than 12, x is less than 3. For your algebraic answers, please write them next to each other. Or write them, box them in. That is an algebraic answer. Okay? What does the graph look like? Well, we are going less than 3. So with a less than shaded to the left, with a parenthesis, greater than or equal to 4, 5, 6, would be shaded to the right of that with a bracket. Why can we keep both this time? Or is inclusive. Make sure when you write your interval, we have two separate intervals, -infinity to 3, 6 to infinity, and it will not be full credit unless you put an or between them. Solving absolute values. We split them. The 4x plus 3 stays the same. Please do not change that. The 7, one side stays the same, and the other side is opposite. The one that is opposite means the inequality also becomes opposite. Then we solve them separately. Do we know if this is an and or an or? I believe my note said that if it's a less than, they tend to be ands. If you're not sure, let's go ahead and just solve them. Where are we at? 4. I'm thinking it's and. Get there. 4x greater than negative 10. Don't leave it as negative 10. Reduce that. Negative 5 halves. Or think of it as 2.5. What would the graph of this look like? I'm thinking it's an and. So I'm thinking 1 and to the left and negative 2.5 and to the right. That makes sense that it's an and because one is shading to the left, the other one's shading to the right, and we, on an and, only keep the overlap. For the one, actually for both, we will have a bracket, okay? Those arrows look a little confusing, so I'm going to take them out. And we only keep the overlap. What does the interval look like? Well, we've got a minimum of negative 5 halves. Please feel free to put 2.5 if that bothers you, or positive 1 here, okay? And you could also do, what was that, negative infinity to 1, and negative 2 to infinity. And I would accept either of those intervals. Just make sure you have all the answers. How do we solve this? Well, the 5 minus 6x splits. That part stays the same. The 12, the first one stays the same. The second one becomes opposite. And when it becomes opposite, so does the inequality. Let's see. Solving here. Negative 6x greater than, it looks like 7, dividing by the negative. X is greater than negative 7/6, or 1 point something. Solving the one on the right. Negative 6x is less than negative 17. When we divide by the negative, the inequality again. Did I forget to do that last time? I sure did. When we divide by the negative, the inequality flips. This one, the inequality will also flip, giving us positive 17/6. Almost 3, 2 point something. Okay? So we're going to graph negative 1 point something, about right there. And 17/6 would be 2 point something a little higher. How does it compare to the 17/6? Well, greater would be to the right. How does it compare to the negative 7/6? Less than would be to the left. And both have the symbol of the parentheses. Okay? Oops. So how would I write that as an interval? Let's see if I can get it without making it disappear. The interval would be two intervals, about negative infinity up to the negative 7/6, or 17/6 to infinity. That infinity kind of sucks, but there you go. These have to be written separate. We have two separate intervals. How do I solve this? Be careful. I have a lot of people that will split this. Don't split this. The note said to isolate it first, so add the 4 first. This is very similar to a quiz question we saw. Splitting it now that the absolute value is by itself, the negative 3x plus 4 stays the same. We get a 3, we get a negative 3. On the negative, it becomes opposite. Solving this now. That's negative 1. So that x is greater than positive 1/3. Notice I flipped the inequality because we divided by a negative. That will probably happen over here as well. Negative 3x greater than negative 7, so that x is less than 7/3. Where's 1/3? Well, 0, 1. 1/3 is kind of closer to the 1, so I'm going to put a line there. Where's 7/3? Well, that would be 2 and 1/3, so a little past the 2. How does x compare to the 7/3? Well, less than is to the left. How does x compare to the 1/3? Greater is to the right. This must be an and. We're keeping the overlap, right? What symbol do we use? Both of them look like they have just a simple parenthesis between them. What would our interval be? A minimum of 1/3, a maximum of 7/3, both with parentheses. Or some of you really like this, 1/3 to infinity and negative infinity to 7/3. I would accept that as well. Solve this algebraically. Some of you are going to do this. So where are we at? 7 minus x less than or equal to negative 1. 7 minus x greater than positive 1. Subtract the 7, subtract the 7. Negative x less than or equal to negative 8. Dividing by the negative, the inequality flips. This one, negative x greater than negative 6, dividing by the negative, x is less than 6. I think this is going to have to be an or by the picture, because I've got, let's say, 0, 1, 2, 3, 4, 5, 6, 7, 8. Less than 6 would be back this way. Greater than the 8 would be this way. Here's the problem. And they're both equal to. Here's the problem. This would not be full credit. This would not be a right answer. Here's why. Let's just check a point. Let's just check x equals 0. If we've done everything right, 0 should be a solution here, right? Stick a 0 up here. 7 minus 0 is just 7. And the absolute value of 7 is 7. Is 7 less than or equal to negative 1? Nope. This should not be shaded. This is not one of our solutions. Check a number past 8, like 9, 10. How about 10? Let's check x equals 10. 7 minus 10, negative 3. Absolute value of that is 3 less than or equal to negative 1? It's not. This is not part of our solution. Would a 6 or an 8 work? If you're not sure, check a number, check 7, right? Any of these numbers, when we plug them in, will not work. It's like, so what's our answer? It ends up being an empty line, an empty set. Why? Some of you were doing this from the very beginning. None of this mattered, because whatever comes out of an absolute value will always be positive, right? And when will a positive be less than or equal to a negative? This has no solution or an empty set. If you notice that, actually if we did an empty set, it would be the brackets with not a 0 but with a line through it, and that would say empty set. So I would accept either of these three. If you had solved it and graphed it and wrote the interval all correctly, you're not getting full credit, but I'm not going to give you 0 credit, okay? So if you can catch it, it's going to make your life a lot easier. If you miss it, you'll be all right. I'm not going to destroy you, okay? Looking at this, split it. 3k minus 2 stays the same. Oops, I'm about to do it. Well, and see, this is where I was like, well, what do I do with the plus 1? Well, we shouldn't have done anything, because I can't split it until we isolate that absolute value. So 3k minus 2 equals 7. Now we can split it. 3k minus 2 equals 7. 3k minus 2 equals -7. 3k equals 9, so that k equals 3. Or 3k equals -5, so that k is equal to -5/3. And I'd be fine with the answer like that. How do I solve it when there's multiple absolute values? It's not that bad. We're going to split it. The first one stays the same, so leave it alone. The second one, the first one also stays the same, but when I split it the second time, the second one becomes opposite. So it's not this. That would be incorrect. It needs to be negative of the entire group. So -2x minus 8. Okay, so once we've split these up, we're going to solve them separately. Looks like this one, I'm going to add the 5x to get 3 is equal to 7x plus 8. -5 is equal to 7x. And so we're looking at -5/7. On this one, I'm going to add the 5x so that I get 3 is equal to 3x plus 8, so that 3x is equal to -5, and x would equal -5/3. And I'd be fine with the answer just in this form. Let's keep going. Almost done with the absolute values, okay? Let's see, this one, solve the absolute value. I'm not going to split it. I caught that from last time. Don't split it yet. Move the 5 first. So that absolute value of 4x plus 3 is equal to -1. Now I could split it, but I'm going to catch from before that whatever comes out of this absolute value is going to be positive. When will a positive equal a negative? This has no solution. If you were to try to solve this, you would get that x equaled -1, and you would get that x equaled 1/2. If I checked either of those, -1 would give me that 1 plus 5 is 4, which is not true. And if I check the 1/2, I would get, let me make sure I did that right. I think -1/2, sorry. If I did -1/2, I would also get, let's see, yeah, 1 plus 5 is 4. And it's not, so this will not have a solution. Okay, no solution, empty set. That would be what I'd be looking for. And this is just to reiterate it, okay? Find the solution for these. Well, if the 8x minus 5 is less than, well, then 8x minus 5 is less than k, and 8x minus 5 is greater than -k. Solving that, 8x would equal k plus 5. Divide everything by 8. Okay. This one, that should be a k, right? -k. Adding the 5, 8x would equal -k plus 5. Divide by the 8. And I don't know why I'm messing with the inequalities here. One's less than, the other is greater than. I need a little closer on that, sorry. So we would say that x is less than k plus 5, x is greater than -k plus 5, and oh, never mind. This I'm making it more complicated than it needs to. Look, this right here, if k is less than 0, then that means that k is a. When this comes out, when will a positive number be less than a negative? this first one will have no solution. So they're trying to reiterate and say, what if k were a negative number? Well then, this first one would have no solution. Why? A positive number will never be less than a negative. On the second one, a positive comes out. When will a positive be greater than a negative? Always. This has infinite solutions. And this, when a positive comes out, when will a positive be equal to a negative? Never. This has no solution. Okay? So verify if the number on the right side is negative. If it's less than or equal to, it will be no solution. If it's greater than, it will be infinite solutions. All right. I'm done with the inequalities. Let's talk about systems. I will be asking you to graph. So you need to be able to handle these. I'm not going to try to make it too tricky. Just make sure that you get each one in y equals mx plus b form. So this one is y equals negative x plus 7. This one, if I move the x, is a little trickier. Negative y is equal to negative x plus 5. We divide by the negative, so that positive y is equal to x minus 5. If I do the first one, I need to start at the y-intercept. Our y-intercept is 0, 7. I don't really have 7 notches, so I'm probably going to just go by 2's so that I can get a y-intercept of 7. And then go what? Down 1 over 1. Down 1 over 1. Down 1 over 1. Down 1 over 1. And we can plot the points like so. Okay? X minus 5, start at a y-intercept of, once again I'm going by 2's, so negative 2, negative 4, negative 5, with a slope of positive 1 over 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. I found where they crossed. Took me a bunch of points, but I found that they crossed at 2, 4, 6, 1. I think we could check these answers. Is 6 plus 1 7? I'm liking the first equation. That doesn't mean it's the answer. It has to work for both, right? Well, the second one says is 6 minus 1, 5. If you're still not liking the graphing, I am going to ask you to graph. But then just feel free to graph it and then solve it algebraically and get a solution and see if that matches your picture. This one, from this point on, I'm really not going to be telling you what method to use. Kind of, use your brain. I will tell you that if there is a fraction, I would encourage you to multiply everything times 4 to clear that out. That would make that, what? A 12x, negative 5/4, nope, the 4 would cancel, a negative 5y, and an 8. This one I think is set up for elimination, where kind of the x's and y's are over each other. So if I'm wanting the x's and y's to eliminate, then this isn't going to work, because right now the x's are the same sign, the y's are the same sign. This is not going to eliminate. So I needed one of them to become negative. So I'm going to go ahead and just say on the bottom, when we multiplied by a negative 4, if I just treated it like a negative 4, everything would change signs. Well, what happens now? Well, the x's will zero out, the y's will zero out, and the 8's will zero out. And we're left with 0 equals 0. What does this mean? Well, these are the same. When these two values are the same, then this is the same line. What does that mean? The book will call that an identity. Or you can say infinite solutions. If I were to graph both of these, and I wouldn't want to because the y-intercept kind of stinks, both of them would be y equals 12 over 5x minus 8/5. They would be the same line. Okay. This one, once again, any method you want. I see how the x's and the y's are already lined up, so I'm thinking elimination again, right? Pick x's or y's that we want to eliminate. Normally, I've heard you all saying pick the smaller numbers. So 2 and 3, we could make them both into a 6. Through multiplication, I would do the top one times 3, the bottom one times 2. The problem with this is that I don't just want them to be the same number, they need to also eliminate. So one of these needs to change signs. How about the top one? We'll multiply it by a negative 3. So that 15 becomes a positive 15x minus 6y, positive 12. This becomes 12x plus 6y equal to negative 12. The y's cancel out like we had hoped, and we get that 17x equals 0. Once again, that does not mean no solution. This is a solution. We can divide by 17. 0 divided by 17 is, this was step 1, this was step 2, step 3, we take that 0 and we plug it in. Where? Doesn't matter. Either equation. I'm going to choose the top one, negative 5 times x plus 2y equals negative 4. 2y equals negative 4. Y is equal to negative 2. That's step 3. Please don't forget, step 4, to write your answer as a point, 0, negative 2. This one, once again, I think is set up for elimination. I got the x's and the y's lined up kind of over each other. So I'm going to say if I want to get rid of the x's, I'm going to multiply the top equation not just by a 2, but a negative 2. So now we have negative 6x minus 8y, negative 16, positive 6x, positive 8y, and 7. The x is 0, the y is 0. Don't freak out. I get 7 equals negative 9, which is not true. When they're not the same, then there's nothing we can do to make them the same. This is a contradiction. This is no solution. If I were to graph these, the first equation would look like this. Y equals negative 3/4 x plus 2. The second equation would look like this. Y is equal to negative 3/4 x plus 7/8. What is true about these equations? Since they have the same slope and different y-intercepts, we are dealing with parallel lines. Hence, there will never be a solution, never be a point in common. Let's talk about 3 variables. This is going to add one big step, and then the rest of it should just be just as easy as what we had done. Our first step is to eliminate a variable, your choice. I'm going to choose, I don't know, the y's look really attractive. I'm going to go ahead and do the z's because I know you all are terrified of the z's. So if I look at this, I'm going to just do equation 2 and 3. And if I took these two, these z's would cancel if I just took that 1 times 2. So 12x, 10y, 2z, and 0. No more z's. So I've got 15x, 20y is equal to 6. Box that in. That's equation 4. That's one of the first steps that we need to do. One of that first step, right? The second one, we have to use equation 1. And I'm just going to use equation 1 and 2 this time. And if I use these two, I need to take the bottom one and multiply it by a negative 3. So the z's will cancel. Top one I'll just bring over. So 3x, 5y, plus 3z equal to 2. Bottom one times negative 3 would be, I don't like that right where it is. I'll put times that one by negative 3 would be, how about negative 18x minus 15y and minus 3z equal to 0. This zeros. This becomes negative 15x minus 10y is equal to 2. We now have equation 5. I actually like these two equations quite a bit because the x's tend to be set up to already cancel, so that's nice. I'm going to just bring this over. The x's cancel, leaving me with 10y is equal to 8, so that y is equal to, not 8/10, how about 4/5. This is not our final answer, right? We've done most of the work. I need to take that 4/5 and plug it into one of our new equations. I'm going to choose the one that's positive. So how about 15x plus 20 times 4/5 equals 6. That becomes 15x plus 16 is equal to 6. Subtracting 15x is equal to negative 10. Do not leave that as negative 10 over 15. X is equal to negative 2/3. We need a z. Good news is we have one in equation 2. So I'm going to take equation 2 and do what? 6 times x plus 5 times y. I'm going to run out of room, I think. Let me see if I got any room below here. Very little, but that'll have to do. 6 times x plus 5 times y plus z equals 0. This cancels, making that negative 4. This cancels, leaving us with plus 4 plus z equals 0. I get z equal to 0. What is our answer? Please make sure you write your answer as a point. The x value is negative 2/3. The y value is 4/5. And the z is 0. That's a lot of work. This is going to be on the test. Next one. I want to choose a variable to eliminate. Now here's the thing. I like this already. There are no x's. So what I'm going to do is I'm going to take that middle equation and I'm going to try to get rid of the x's. I'm going to multiply this one times a negative 4 so that I get negative 4x plus 4y plus 4z is equal to negative 16. And the other one now, the x's can cancel as well. Goodbye x. How about 5y plus 5z is equal to negative 5? So, because this one already had the x's gone, right? I just took the other two and got rid of the x's. So now I have my equation 4 and 5, my new equations. I need to choose another variable to eliminate. I'm liking the y's because they're smaller. I just need to take equation 4, multiply it by a negative 5, get negative 5y minus 10z equals 0. So I get negative 5z is equal to negative 5. Dividing by the negative 5, z is equal to 1. We're not done. Really close, but we're not done. We need to take that 1 and plug it in. Which equation? Well, I like equation 3. Y plus 2 times 1 equals 0. Y plus 2 equals 0. Y equals negative 2. We're not done. I still need a z. Where do I get a z? Go back to the original equations. I'm sorry, I need an x. Go back to the original equations. I'm going to choose the middle one with a single x and do x minus y minus z equal to 4. X plus 2 minus 1 equals 4. X plus 1 equals 4. How about x equals 3? So what's our answer? Make sure you write that as a point. 3, negative 2, 1. Let's talk about a word question. Oh boy. Okay. I'll probably need to work this out a little bit on a separate piece of paper, but this is going to be looking at, we are making 100 ounces of a mixture that sells for 0.83 cents per ounce. So we have a cost, an amount. Okay. I'm going to set these up and I'll work it out on a separate document. But what we did is we said, okay, I see that we're making 100 ounces. That's just a total amount. So our total amount is 100 ounces. How do I get the total amount? Well, however much X that we use, that would be, we'll call orange Pico, we'll call that orange X. We'll call the Irish breakfast Y. And we'll call the Earl Grey Z. However much of those three that I use, they should total 100. The amount of X plus the amount of Y plus the amount of Z should equal 100. That's our total amount. Now we have to do a cost. That's every cost of X times the amount of X plus the cost of Y times the amount of Y plus the cost of Z times the amount of Z is going to equal our total cost times amount. I'll get to that in a second. I'm going to start filling this in. What is the cost of orange Pico? Well, 83 cents times X, whatever that is. What is the cost of Irish breakfast? What was it? 80? I'm messing up already. Orange Pico is 80. Okay. Irish breakfast is 85 times the amount. The cost of Earl Grey is 95 cents times Z. And what will that equal? Well, it's going to equal the 100 ounces times its value. So the mixture has a value of 83 cents times 100. It's still the cost times the amount. We're making 100 ounces in the mixture. So we're basically taking everything from the previous equation and multiplying the amount of X times its cost, the amount of Y times its cost, the amount of Z times its cost, and the total times its cost. Okay? One more equation. He wants to use twice as much orange Pico as Irish breakfast. So orange Pico is X, and it's twice as much as Irish breakfast. So it's 2 times the amount of Y. We now have 3 equations. In fact, I like this a lot. I'm going to, like I said, fill this in a separate piece of paper. But I like this because the third equation doesn't have Z. So if I'm wanting to get rid of a variable, I'm probably going to take the first 2 equations and get rid of Z. Okay, so like I was saying, I'm going to like this just the way it is, without a Z. I'm going to take these 2 and I'm going to try to get rid of the Z. This right here is just 83 times 100. I'm going to just rewrite that as 83. And if you don't like the decimals, then I'm going to take this whole equation, multiply it times 100, so that we get 80x, 85y, 95z, and 8300. Now, if I'm wanting to get rid of z, because once again, this first equation that I really like doesn't have a z, I'm going to take that top equation and multiply it times negative 95. Why? That will get rid of the z. And what's that? 9500. Z's are gone. Left with negative 15x minus 10y is equal to negative 1200. I don't mind these 2 equations, but really to me, this is not set up for elimination. This is set up for substitution. How do I know? I already have an x equals. X equals 2y. So I can take this x right here and replace it with a 2y and get negative 30y minus 10y equals negative 1200. Negative 40y is equal to negative 1200. And by dividing by the negative 40, we find out that the y is going to be 30. We are going to use 30 ounces of the middle T. What do I do with that 30? Plug it in. Look, x equals 2y, right? So that means if y is 30 and x is equal to 2y, then x must equal 60. How do I get z? Well, I go back to the easiest equation we have, which was x plus y plus z equal to 100. And if these two, 30 plus 60, if 90 plus z equals 100, then z must equal 10. Is it right? We could check it, right? Check it with the cost. What was it? 80 cents, 85 cents, and 95 cents, right? So 80 cents times 60. So it was at 0.8 times 60 plus I think it was 95. No, it's 85, then 95. So 85 times 30. So 0.85 times 30 plus our last one, which was 95 times 10. Make sure. And what that should give us is $83. Should give us the 83 cents times 100, or $83. If we've done this right, this should equal 83. I'm liking my answers. All right, let's keep going. Determine if it's a function. What's a function? Every x goes to exactly one y. We can check that with a vertical test. We can check it by saying this x goes to 1y, this x goes to 1y, this one goes to 1y. Yes, it is a function. What is the domain? The inputs, or the x's, would be 2, 4, and 1. The range, the outputs, or the y's, would be the 3 and the 2. On B, this is a line. A line is a function. If I draw vertical lines, they only cross once. This is a function. What is the domain? This goes left forever, right forever. All real numbers. Or you could put negative infinity to infinity. What is the range? It goes up forever, it goes down forever. Put all real numbers, or negative infinity to infinity. On C, is this a function? Nope. How do I know? Well, when I draw a vertical line, the vertical line test crosses twice. So this one is not a function. You can still see the domain though. The domain are the x values. It goes all the way to the left to -1, all the way to the right up to 7. So it would be between -1 and 7. The range, it goes all the way up to 3, all the way down to the 1, so it would be between 1 and 3. And last, here we have a third degree in x cubed. Is it a function? Any vertical line crossing more than once? As long as it doesn't, then yes, it is a function. What is the domain? It goes left forever and right forever, all real numbers, negative infinity to infinity. What is the range? It goes up forever, down forever. So all real numbers or negative infinity to infinity. 30. I need to see the functions. Alright, so fg of negative 2 means f of negative 2 times g of negative 2. I don't need to find fg of x here. I can just put a negative 2 in for f, a negative 2 in for g, and then multiply them. So what is f of negative 2? Negative 2 squared would be 4. 3 times negative 2 would be minus 6 plus 2. I think this just becomes 0. What is g of negative 2? Negative 2 plus 1 would be negative 1. So what does this end up becoming? F of negative 2, 0 times negative 1, 0. That would be fg of negative 2. How do I do f over g of x? Well, I would take f of x and divide it by g of x. You do need to simplify this, and the top will factor, so that becomes x plus 1 times x plus 2, so the x plus 1's cancel. So I end up with just being x plus 2. Now be careful when I do f over g of negative 2, because yes, I can stick a negative 2 in here, and just get negative 2 plus 2 is 0. But you need to verify, because of the domain, that there aren't any restrictions when I do f of negative 2 divided by g of negative 2. There's restrictions here, right? Well, what was f of negative 2? We got that earlier. That was 0 divided by g of negative 2, which was negative 1. Is that still 0? Yes, it is. And if it is, then that is our final answer. When wouldn't it be? What is the restriction on the domain? Remember the g of x cannot equal 0. So x plus 1 cannot equal 0. X cannot be negative 1. So if I asked you to do f over g of negative 1, you would get 0, but when I checked it, it wouldn't be right. So be careful with that. Last but not least, what is f minus g of x? Well, it means f of x minus g of x. What was f of x? Minus what was g of x? This would be wrong. I need to minus the entire function so that it becomes minus x minus 2. So we end up with, looks like, x squared plus 2x, because the 2's cancel. And that would be f minus g of x. Last page. ff of x. What does ff mean? F of x times f of x. That would mean 3x plus 5 times 3x plus 5. We would distribute that, get 9x squared plus 30x plus 25, and that would be ff of x. What's g of x plus 1? Well, I would go to the g function, and everywhere there's an x, we're going to replace it with an x plus 1. So instead of putting 3x, it'll be 3x plus 1 plus 5 all over x minus, nope. In place of that x, put a x plus 1. That goes in place of both of the x's. We should simplify that, so on the top, 3x plus 3 plus 5 all over x minus 1. So how about 3x plus 8 over x minus 1? And that would be g of x plus 1. What is fg of 2? Well, I could do f of 2 times g of 2. Or I could put a 2 into the answer of a, and it would be what? 9 times 4, 30 times 2, plus 25, 360 plus 60 plus 25, 420, 445. Or I could do f of 2. F of 2 would be 11. Times g of 2. G of 2 would be 6 times plus 5, 11 over 0. Uh-oh, we got an issue. See, there was no restriction, right, with... Oh, that was f of x. I was mistaken, wasn't I? So all of this on the beginning was a mistake anyway. But the issue here, all of this was a mistake anyway. So f of 2 is 11 times, this becomes 11 over 0. We can't divide by 0, right? So this would have no solution, or it is undefined, I guess would be better. Why? Because g of x has a restriction right here that the domain cannot equal 0, so x cannot equal 2. So anywhere I'm asking x to equal 2, that would not be correct. Last, how do I do f over g of x? Well, f of x wasn't too bad. That was 3x plus 5. I don't feel like dividing by a fraction, so I'm going to treat this as divided by the fraction of g of x, which was 3x plus 5 over x minus 2. X minus 2. How do you divide by a fraction? We multiply by the reciprocal. X minus 2 over 3x plus 5. What's kind of cool about this one, which is why I did it, is the 3x plus 5 would simplify this time, right? This group would cancel with this group and leave me with just x minus 2. So I like how that simplifies, but I do want to encourage you again, there are restrictions on this domain. See, the original function, the original g of x cannot be 2. So that means in this example, the domain x can still not be 2. But the other issue was that we put a 3x plus 5 in the denominator. So actually we would also get that 3x plus 5 cannot equal 0. So we would have a second restriction on the domain, which would be negative 5/3. I like to introduce this and bring it in. I'm not going to be testing you on restrictions on the domain, except I could ask you to do something that puts a 0 in the denominator, and you would need to know that's undefined there. Okay? It's going to be a big test, so get yourself prepared, and I will see you guys for the test.